Episode 129 of CppCast with guest Arvid Gerstmann, recorded December 6, 2017. This episode of CppCast is sponsored by Undo. Debugging C++ is hard, which is why Undo's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo.io to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice, CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CppCast during checkout at jetbrains.com. In this episode, we talk about exceptions versus return codes. Then we talk to Arvid Gerstmann from Appico. Arvid talks to us about a range of topics, including building his own C compiler and FASTBuild. Welcome to episode 129 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing pretty well. How are you doing, Rob?
Doing okay. Getting into the holiday spirit, I guess.
Good. Well, there's a local channel that plays, nothing but Christmas music from Friday until, that's just the radio station that my car is set to now.
Yeah, my wife always likes to listen to all the holiday music, too. I can kind of take it or leave it, but I'm not opposed to it.
I love it, even though it's like the same 10 songs over and over again, basically. I just keep singing along. I'm okay with that.
Same 10 songs played by like a dozen different singers over the years, yeah.
Yeah.
Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got a tweet. You should like this one, Jason, from John Foltz. Referencing last episode at 16 minutes and 15 seconds, you mirrored his frustration with CMake docs. A great tool, but impoverished documentation makes for a steep and unpleasant learning curve. Doesn't help that Google hits never seem to target the up-to-date docs.
Yeah.
Yeah.
There was a later tweet in that conversation there that said that Google that the wiki pages aren't even officially updated, I guess.
Oh, really?
Yeah.
Well, there's another tweet that I want to point out to you. This guy, Kai Wolf, is saying he is trying to fix that, meaning the bad CMake documentation. And he linked to effectivecmake.com. It's effective-cmake.com. And it looks like he's writing a book or maybe an online book. And it currently says it's at like 40% completion.
Yeah.
But maybe we should have him on when he's a little bit closer to being done with the book.
Yeah, it looks like he's self-publishing it, if I am understanding that correctly. Yeah. It's an ambitious project.
Yeah, definitely. Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes. Joining us today is Arvid Gerstmann. Arvid is a passionate programmer and computer enthusiast with a focus on writing high-performance C++. His area of expertise includes, but is not limited to, writing compilers, implementing the included standard libraries, and creating game engines and games. He is currently the CTO of Appico. If he is not programming, he enjoys reading books while drinking a nice cup of self-brewed coffee. He currently lives in the sunny Hamburg, Germany. Arvid, welcome to the show.
Welcome. Nice being on here.
Yeah, but is it sunny this time of year?
No. That is the joke in that sentence.
Okay.
Hamburg is not exactly known to be sunny. Unfortunately, we are right now in the very dark and very rainy season of the year.
No.
Do you get a lot of snow where you are?
No, unfortunately not. We used to. Hamburg has a very big lake in the middle of the city, And a couple of years ago, the lake froze, the complete lake. And what Hamburg City decided is to put the whole Christmas market on the frozen lake, which is actually pretty damn amazing if you think about it. And was a lot of fun, but since then we haven't had that much snow, unfortunately. And if we get snow, it becomes icy very quickly and not white anymore, brown snow. But it's not much fun, no.
That's unfortunate.
Yeah.
Okay, well, Arvid, we got a couple news items to discuss, so feel free to comment on any of these, and then we'll start talking to you about all the projects you have going on, okay?
Perfect. Sounds good.
Okay. So this first one is Intel offering their parallel STL implementation to new libstd C++. I thought this was a pretty interesting offer, and apparently I think they offered it to Clang as well.
Yeah, I saw a follow-up comment, I think, from Marshall saying that they offered it to Clang as well, but I did not see any conclusion to either of those offers if they were accepted.
Yeah, this was made pretty recently, just about a week ago. It looks like it went out.
This is where those two standard library implementations are still lacking, but I believe the Visual Studio implementation is quickly coming into compliance.
Yes.
Yeah, I think I saw some tweets from STL this week that they're already at like 75%, I think.
If you follow Billy O'Neill on Twitter, he's working on that and tweeting about his progress very, very often and very, very good, actually.
His progress and or frustration with implementation of it.
Yes.
Yeah. Okay, next article is from Funathan's blog, Exceptions versus Expected, Let's Find a Compromise. And it looks like this blog post was actually in reference or in response to two earlier blog posts, one from Simon and one from Vittorio, both past guests on the show.
Yes. Have you been following along with this discussion at all, Rob?
I read this post. I didn't have a chance to go through Simon and Vittorio's post yet.
You've been following this somewhat, Arvid, I believe. I've seen your comments on Twitter.
I've been following that, yes, of course.
Yes. This has
I
been...
have a very strong opinion on exceptions.
Okay, well, I'll give a quick summation, not of the full argument, but just of what's been going on. There's been back and forth, like 4 blog posts now, plus associative Reddit discussions. And we don't have mentioned in the news that Tartan Llama just posted on his blog the call for more data on exceptions. So now that's 5 articles and a very long Twitter thread also about exceptions versus using algebraic types for returning error data. So go ahead and give us your strong opinion now, Arvid.
Actually, yes, I have a strong opinion against exceptions. And I found the blog post by Jonathan actually very, very good. He did a perfect summary of why exceptions are usually not the best thing you can have, but sometimes are desired. And although he did a very good blog post, I think boost outcome should have had more prominent shout out, I guess, because it actually offers you a perfect symmetry between having algebraic data types and having exceptions. So the blog post mentions the double interface of boost file system, which has one function which calls, which throws, and one function which is returning an error code in an odd variable. And if you use boost outcome, for example, you can replace that with one single function, and this function, based on how you call it, will either throw or return you an error type, an error code, which you can then handle.
How does it still has to be based on what parameters you pass to it or something, right?
It is an out parameter. No, it's not it's a return value. It has boost outcome and then the value and an error. So it's similar to expected, but you can replace exceptions with that. And based on if you have turned them on or off, you can use them or just crash or use the return value.
And I have my perennial complaint with all of these types that it makes you have to reason harder, if you will, about the lifetime of your objects. When you're returning something into an algebraic type, do you now need to use std_move to get the efficiency that you would have gotten with return value optimizations in the past? And when you get the algebraic type back out on the other end, if you need to extract that object, you have to pay the cost of another move. which is not free. It is a thing.
And that is absolutely, I share that sentiment. It makes a big it doesn't make that much of a big difference, I think, but it can make a difference if you have tons of those, and especially given that exceptions, if they don't throw, are basically costless.
Right. And in the hypothetical case that you've got something that, like a stood array that you're returning that doesn't really have a move mechanism, it could be potentially expensive.
That is potentially very expensive. I've seen that in code I've implemented on my own where I have something similar to stood expected. And yes, if I have a type which is not movable, I usually go for a different solution, maybe an alparam or something, because it just is too expensive to use.
Well, so all of our listeners can go and read all of those blog posts and read up on the 30-message Twitter thread or whatever it was and make your own opinion.
It's a big Twitter thread.
Yeah.
Okay, this next article is from the Jupyter blog, and it's about interactive workflows for C++ with Jupyter. And I feel like we've talked about Jupyter on the show before.
We've mentioned it.
We have mentioned it, but I wasn't really sure what Jupyter is used for primarily. Do you remember, Jason?
In my head, Jupyter is like this program, I don't even know if it still exists, that was called MathCAD.
Okay.
MathCAD? I think that was the right word. Where, now I have to try to Google that.
Do you mean You don't mean MATLAB?
I don't mean MATLAB.
Okay.
I have seen Jupyter used in a lot of Python-related codes.
Okay.
Especially math, something you will implement in MATLAB, and then port over to Python, Jupyter's notebook.
Yeah. So the basic concept is that you can program or generate whatever, graphs, whatever, computationally inside the middle of a document to some extent. So you can write like a paper up and have it do the calculations and the graph generation in the middle of the paper for you. Correct?
That's what I've seen, yes.
Okay. And that's what MathCAD is. Yeah. MathCAD does still exist, just for the record. The initial release was 1986.
Oh, okay. And I guess this article is talking about how they can now embed C++ code in along with, the graphs and such that you're talking about?
Yes.
Okay, that's pretty interesting. And
with a proper API, so you can use C++ to generate GUI components and whatever in the middle of your document.
That's awesome.
And graphs.
Another great use of Cling.
Mm-hmm.
Yeah, I personally have often felt like Cling is a solution looking for a problem, but I really do like the idea of using it here.
I can offer you a problem later on, because I have one.
Okay.
Although I haven't yet, I looked into Cling, but I found it to be very undocumented. Yeah.
But you are using it?
I've been looking into using it. Right now I'm using kind of a workaround, just calling Clang in a subprocess. Which works, but is really not that cool solution.
Right.
Okay. And then the next thing we have, and this isn't really an article, but more of an announcement, that the ISO C++17 paper is finalized. We already talked about how that basically was accepted a couple months ago, but you can now actually go and buy a hard copy of the standard if you want to.
Or a PDF.
Or a PDF, yeah. Is that something you guys have ever done? I mean, I've never thought about buying a hard copy of the standard, but I guess if you're a compiler writer, then you definitely need it.
Even as someone who's implemented a C compiler, no, I haven't.
I can see, so it's supposed to be only cosmetic changes from the last final draft of a particular version to this PDF. But if you were like working at Microsoft or something, I could see having the official copy so that you know what those differences were would be valuable.
Yeah.
And with current exchange rates, so our listeners know, it's approximately 200 units of money, regardless of what your currency is, right? I mean, we're fairly close in the euro, the Swiss franc, and the dollar at the moment. Fairly close.
Yeah, I wasn't on this link I have. It's not showing the rate in US dollars. It's showing it in CHF, which I'm not sure
that's
what
Swiss franc
is. That's Swiss francs. Okay.
Yeah.
Interesting. Okay, and then 2 more quick announcements. We have a call for submissions from C++ Now, which is going to be in Aspen again in May 6th to 11th, 2018. And how long is that call for submissions open?
February?
Due January 24th.
January.
Yeah, and they'll send out decisions on the 26th of February.
Do you have your plan yet, Rob?
No. Do you?
I do actually have my plan. Do you have your plan, Arvid?
I have 1 or 2 talks in my head, but I'm not decided yet, so I gotta do some brainstorming there.
But you are going to submit and consider coming this year?
I do.
Would this be your first year to C++ now?
It would be, yeah.
Okay, that's what I thought. It's a fun conference. Highly recommended.
And then we also have an announcement about the Embo++ conference, saying that they're also doing a call for papers, although you just have this tweet here. Do they have an actual link on a blog, Jason?
I actually couldn't find a link, but I wanted to make everyone aware that this was published in November, late November, that they still have a call of papers open until the end of December. And it'll be, I guess, too late for our listeners to buy an early bird ticket. If I read the website right, the early bird tickets expire tomorrow. But, yes.
Okay, well, Arvid, let's start talking about, first of all, this C++ tour that you were working on.
Yes, that's a project I want to actually announce here. I haven't talked to anybody about that. I wanted to take the unique opportunity. Yes, it's a project which started on the CPP Lang Slack, actually, and it aims to create a kind of interactive tour through the C++ language, showing big programmers who begin programming in C++, but maybe have some experience in other programming language, how do you write C++ code. The idea originally stemmed from the Golang tour, because if you go to the Golang website, golang.org, there's a input window for writing Go code, and there's a little tour button, and if you click on that, you come to a separate page, and it guides you through every feature or through most features of the language, like here's how you write a function, here's how you write an interface, here's how you slice an array, here's how you declare a map, and so on and so forth. And the C++ tour is aiming to provide the very same for C++, showing you how to write a function, how to declare a variable, and maybe even a little and later have a tutorial for beginners, so complete beginners can jump right in, have a list of lessons where they can go through, like writing your first program. And then obviously everything will be dynamic and interactive. So you will always have a code editor on the right and the lesson on the left, allowing you to write code and see the lesson and test everything you just learned. Another extension we might have in the future is to show new language features for already experienced C++ programmers. So, for example, for the C++ 17 standard, we could show, hey, this is an optional. You can use optional like this. It is useful for that specific reason. And here's constructor, template, deduction, whatever.
What are you going to be using for the interactive compiler? Is that going to be with Cling that we were just talking about?
No, right now the solution is to use Wandbox, because Wandbox actually offers us a full API.
Okay.
Although in the future we might consider migrating away from that and building our own system, but it's in very early stages. We started working on it like a week ago, and decided on Wandbox first.
So, what is the current status?
Our current status is we have started, and we are looking for people to help us making that happen, because my goal is to make this a community effort, like CPP references, for example. So you will always have, if you have the lesson on the left, you will always have a button to go through GitHub. Everything is right now hosted on GitHub, to open an issue with the lesson or even edit it directly and submit the changes to us. Yeah.
Okay, so do you have, what website should people go to get involved?
Right now, the best way to get involved is to go to github.com/leanros/cpp-tour.
Okay.
Or hit me up on Twitter, hit me up on the CppLang Slack. I'm at Arvid Gerstmann on Twitter and Arvid on the CppLang Slack.
Okay.
Every person we're right now we have four people, and every person is appreciated to help with the project.
It sounds like a pretty ambitious project. Like it could be a virtually unending project, really.
Yes. I have a talent for starting such projects. Although I actually plan to go through with that because it helped me immensely of getting to actually start writing Go, although I haven't done that in a long time. All the other languages I look at just to try out is like, here, download that compiler, that IDE, install this, and 5 hours later you got yourself your working environment. And just to have a tutorial where you can jump in and start writing code the second you start it is just priceless for me.
Yeah, or 5 hours later you're still wondering why your IDE can't find the compiler you downloaded.
Yes, exactly.
Yeah, that's it sounds like a really good goal. Do you have a specific outline of what things you want to cover first so people can start contributing straight away?
Yes, we have a couple of issues opened, and there's a list of lessons we are A, working on, or B, we want to start working on. So you can just look into that and start writing lessons, and we can then talk about including them and making that happen.
So I'm kind of curious. I mean, you said you're using Wandbox, which I know does not show the disassembly like Compiler Explorer does.
Yes.
And I've kind of gotten to this place in my own talks that, I show Compiler Explorer, and whether or not the assembly is actually relevant to the particular thing that I'm discussing, it's there. Like, this is a normal thing. We should all be used to reading x86 assembly. And I don't know if I've gone off the deep end here or not. So... What did you guys talk about that at all in your determination for what to show and how to interact with the user, the learner?
We looked into that, and it appears that Compiler Explorer, actually has an API as well.
It does, yes.
In the future, we will probably make use of it, but hide it under some sort of settings or button just to not confuse the beginner first.
Okay.
Yeah, I think the beginner is more interested in seeing the return of the program and not the disassembly output.
Yeah, well,
If you come to the point where we can show new features like optional, having the disassembly is absolutely useful. I agree with you.
Yeah.
Okay, well, do you want to tell us a little bit about your background in implementing high-performance systems?
My background? That's a long story. Long story short, I've started implementing games, and it all rolled from there on. Given that you need to have 60 frames per second nowadays, or even back then, and you have 60 milliseconds for that for a single update loop, you have to consider a lot of stuff very, very differently compared to the normal C++ programmer.
So, did you work on any games that any of us would have heard of?
Probably not.
Probably not.
Probably not. I did a lot of game implementations behind the scenes. The only games I've published so far are mobile games.
Okay.
Unlikely that you've played any of those.
Never know, but...
You never know. It's right. You can search for Tesla tubes on the App Store, for example. It's by Kilo and our Studio Vuni games. It is written in at a time where C++ 11, C++ 14 were currently very new. Mm-hmm. And a lot of my current opinions on C++ stem from that project, actually. Since Auto was new, and since, you got new stuff, you use it. And almost always Auto is not a rule I follow anymore. I said that.
Well, that's interesting, I guess, a side diversion here. So you used to follow almost always Auto, and now you don't, you're saying?
Yes, I pretty much had Auto everywhere, and even if I haven't had Auto, I use decal type of something I declare with Auto. So I took it very far.
Right, that's pretty extreme, yeah.
And at one point just noticed, this code becomes kind of unreadable if you put auto literally everywhere.
So do you still use auto though?
Yes,
today?
Of course. Auto is wonderful, especially for something like if you have an option return, I put that in an auto, or if you have iterators. But the usual stuff, or the usual what a lot of C++ programmers praise is like you declare an int and you put auto I equals a number. I don't see the value in that anymore.
Yeah,
that's an interesting perspective because I think I've read some people who have gotten so turned off from auto that they've gone the opposite way and they basically don't use auto at all. And I think that's a real waste right there.
That absolutely is. Auto has absolute uses. It's just the rule of almost always auto is probably not always good to follow.
Right. You're okay with bool. You're okay with int every now and then.
Absolutely, yes.
Cool.
And auto has some uses where you can't get around it. I mean, if you have a lambda which is generic, for example.
Right. Yes. So in your quest to hit 60 frames per second, were there common performance issues that you ran into?
Common performance issues is usually there are some common things. Yes. One of the many things Donald Knuth said is like premature optimization is the root of all evil. And I found that to be true in a lot of cases. You write some math code in intrinsics and it turns out to be, slower than what the compiler actually does.
I like that. I would love to see examples of that.
Yeah, we'll have to see them too. I think I've eliminated them in the engines we used in the past. At least I hope I've eliminated them. Let's say that. One of the other common issues I've found is just as you, I like seeing and I also like writing x86 assembly or assembly in general. Mm-hmm. And I did rewrite a bunch of math code or a bunch of other code in assembly, which also sometimes turns out is not always the best idea to do. Sometimes even assembly can be worse than what the compiler, even handwritten assembly you looked at and think it's the best thing, can be worse than a compiler can do nowadays. Compilers are very, very clever.
Yeah, I just realized we mentioned intrinsics. You had mentioned intrinsics, and I don't know if they have ever come up on the podcast before. Would you mind explaining to our listeners what intrinsics are? Sure.
When we talk about intrinsics, I think we are talking about the Intel intrinsics generally and mostly. The Intel intrinsics are direct access to the underlying x86, SSE, SSE2, SSSE3, and so forth, and AVX instructions. So you have, for example, it's an idiom called SIMD, single instruction multiple data. You have a packed byte array, let's say that, which contains 4 floats or 2 doubles, for example, and then you can do a mathematical operation on that. You can multiply those 2 floats, those 2 doubles, or multiply those 4 floats with another 4 floats, which allows you to, for example, if you do operations on a vec4, on a vector of 4 floats in one single instruction, instead of 4 separate instructions.
Okay. And your experience was you went through all this hard work of using these intrinsics and it didn't necessarily gain you anything.
Sometimes it doesn't necessarily gain you anything. Exactly. This usually comes from if you have a ton of code which is doing mathematical operations, and sometimes the compiler is clever enough to eliminate all the writes and all the reads you actually need in between. But since you're using intrinsics, you kind of hide what your actual intent is, and hiding the intent from the compiler is usually not a good thing. Though this has been quite a while back. I'm not sure if compilers still do that. I would say they don't.
You're saying there's better chance that they can see around your intrinsics and still optimize the code?
Yes, they optimize around intrinsics a lot nowadays, and I think they also used to do back then. But if you do something like switching between AVX or SSE in the middle of some other operation, you pay the price for that, for example.
Yeah, I can imagine. It's not good to confuse your compiler.
No, definitely not.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. You have an extensive test suite, right? You're using TDD, continuous integration, and other best practices. But do all of your tests pass all the time? Getting to the bottom of intermittent and obscure test failures is crucial if you want to get the full value from these practices. And Undo's live recorder technology allows you to easily fix the bugs that don't otherwise get fixed. Capture recordings of failing tests in your test suites and debug them offline so that you can collaborate with your development team and customers. Get your software out of development and into production much more quickly, and be confident that it is of higher quality. Visit undo.io to see how they can help you find out exactly what your software really did as opposed to what you expected it to do, and fix your bugs in minutes, not weeks. Since we're talking about compilers, you mentioned when we brought up the ISO C++ paper availability that you have written your own compiler. Do you want to tell us a little bit about that experience?
Oh, I have, yes. Many call me a madman for doing that. I have written my own C compiler and my own libc. In hindsight, might have been not the best idea I ever had. But it was fun. I have an interesting, let's say, side on C++ or relationship to C++, that I write a lot of C++ and then I see some terrible code or write some terrible code and just jump back to C because, well, it's easy and simple, and then I see why C is not the best language always to implement something. And my usually the normal thing you would do is to go back to C++ and implement it in C++. I did implement my own C compiler and implemented a few extensions on top of it. Like I wanted to have RAI, R-A-I-I, and implemented the RAI GNU extensions, I think, which kind of allow for a similar idiom to use in C.
Interesting. I didn't know that existed.
I think glib, the GTK standard library, uses that a lot.
Oh, okay. I believe that, from what I know of it. Well, glib is kind of like, it's an entire framework that should have been written in C++. Yes. That's written in C.
Yes.
I know if there's any C fans listening, they'll probably think that I just made a terrible comment there, but it's totally true.
It is object-oriented. It is using RAI everywhere, and it is using many more C++ idioms. I don't know right now, but I guess. And it definitely should have been implemented in C++, or at least something which has those idioms or supports them in the language.
Right. So how far did you get with your C compiler?
It works. It compiles. It is self-hosting at this point.
Oh,
actually.
Wow.
It works. It does miscompile still, even after working on it for like 2 years now, I think. Writing compilers turns out to be quite hard.
So is there anything that you learned that C can do, that C++, that you wish you could still do those things in C++, if you will?
Yes. Now if we talk about current C++, yes, there are things you cannot do in C you can do in C. One of those is, for example, I always forget how they're called. Let me Google that real quick. It's kind of bad.
Googling.
Yeah, as the resident C guy, I shouldn't forget how the features are called. Anyway, C99 introduced a feature which is called compound literals, for example, where you can have a function call which takes a struct, for example.
Uh-huh.
And you can then, which takes let's go back. It doesn't take the struct by value, but it takes the struct as a pointer. It takes the pointer to this struct. You can then declare that struct inside this function call and pass a pointer to it. So it creates a temporary object, passes the pointer to the function, and then executes the function and returns. This is a way in C to get named function arguments, for example.
Okay.
It's a beautiful and wonderful feature. Nobody knows it, and it's one of those features where you can tell or go to a C++ programmer and say, we can do that in C. Can you do that in C++? And they look at you like, what is that? That is pretty cool, actually.
So that works because you can what's it called? Where you can initialize values of your struct by name in C.
Yes, there's designated initializers.
Which has just been approved for C++ 20, I believe.
Correct, yes.
Okay.
It will come in C++ 20 with a few minor tweaks, though. For example, designated initializers in C allow to zero initialize everything. So if you have a designated initializer and you are initializing your struct, all members you do not name will be initialized to 0.
Okay.
In C++, this will not work.
But you could give them default initialization values, I would imagine.
I would imagine that. I haven't looked that detailed into the proposal, but I think you talked about that on the podcast as well, if I remember correctly, with I think with Gore.
Perhaps.
Yeah.
And he mentioned that, for example, that you also cannot declare variables in other order than they are defined or declared in the struct, which you can do in C, for example. Okay. It all makes sense in a sense of C++ because you have default initialization and one member can depend on another member, so you have to initialize them in the correct order.
Yeah. That's, although I've never thought about using, like for me, the designated initializer, I'm like, that's interesting, but why do I want it? The idea of using it as basically named parameters, passing them into a function, like you're saying, but in this case, using a const reference stack variable, it could be pretty cool.
That could definitely be pretty cool, yeah.
So in addition to writing your own compiler, you said you also wrote the standard library to use with that compiler?
Yes, I did. It is, I think, so far the only C11 libc I know of which runs on Windows.
Oh.
Wow.
That I know of. There might be one which actually runs on Windows. But
it's not the MinGW implementation, C11?
This is glibc. This is the GNU ABI. This is not using the normal MSVC ABI. Mine is using the MSVC ABI, yes. The glibc runs on Windows and is C11, correct.
Okay.
Well, there goes my argument.
Well, but that's so that's also a side comment that the Visual Studio one isn't quite up to C11 yet, right?
No, it is very good in terms of C99 right now because C++11 required C99 features, and even though the MSVC compiler is commonly known as a very bad C compiler, it does actually support C99 features which are not available in C++, like the designated initializers and the compound literals. So it's kind of far since MSVC's C98 heritage.
Right.
C89, sorry.
C80, right. Are you ever tempted to enable the extensions on the compiler that you happen to be on that would let you use these C features in C++? I have to assume GCC at the very least would allow you to do that.
GCC allows you to use designated initializers, for example. Yes, I actually have never turned them on, honestly, now that you say it.
I'm not suggesting you do. I'm just wondering if you've done it.
I should give that a try, actually. I'm interested how designated initializers are actually implemented in C++ on GCC.
Right.
Did you run into anything particularly difficult when implementing your own standard library?
Difficult, yes. The standards are very vague compared to what we actually think of. Both in implementing compilers and implementing standard libraries, the documents try to not define anything. Like the C standard, for example, tries to very, very hard to not define what a pointer is.
Really?
Yes, and so do the standard libraries. Obviously, are defined in the function. This is the function. This is what the function takes, this is the input, and this is what the function should output. There's one or two guarantees you have to think about, but that's about it. You can achieve that in any way you want.
So when you say that it tries really hard to not define what a pointer is, for example, do you mean they try to not say like what size it should be just so that it can work on any kind of system? Or do you mean that they like don't even specify at all that a pointer is something that points to another location in memory?
They don't specify that at all as far as I know, because of, for example, segmented pointers. In the good old DOS days, you had far and near pointers. And so they could, for example, be not actually emulating a linear memory you have like right now, but something very, very specific or different, I guess.
Right.
Both C++ and C still try to be super portable to very niche systems. You can run C compilers on these Ps where there's like 36-bit ints and no other size. Everything's 36-bit or something.
You like that idea, Rob? 36-bit everything?
No, no I don't.
I think PDP-11 also had 36-bit words. Was it something like that?
Yes, that sounds right. Yeah, something like that, yeah. I was recently looking at a system, and I almost never talk about C++ Weekly on here, but I might be talking about this system on an episode coming up. That was 12-bit words, I believe, for everything.
Oh, what system was that?
PIC16. It's an embedded.
Never heard of that.
Microchip still makes the PIC microcontrollers. This was a particularly old flavor of it.
All right.
I'm going to have to double check the specs on that before I make an episode about it, of course. But yes, anyhow.
But yeah, that's the problem, let's say, of C and C++ to some extent, that they try to be portable as much as possible and be as vague as possible as well. A lot of my problems actually came from the preprocessor. The preprocessor is, in my opinion, very underdefined, what it actually allows you to do. There's a few things like this is UB in the preprocessor, or this is implementation defined. Please do not depend on it in your code. But I think I can think of 2 or 3 different passages where this is the case for the preprocessor, and everything else like, yeah, this is the macro. Please give us this as a preprocessed output. How you do that, what you do in the end, I don't care.
Did you take any liberties then when you were implementing your own version to make it better or different?
My restriction came from I wanted to use my previously written C code, and which was written on MSVC and was using the MSVC standard library or the Windows headers to some extent, rather, not the library. And to use the Windows headers, I had to implement some of the extensions which the MSVC preprocessor uses.
Okay.
Some of which are technically undefined behaviors. So your program, if you include any Windows header, is technically undefined.
Well, that means that every program that includes a Windows header should just return 0 and exit, basically, right?
I wouldn't take it that far, but there's this one particular construct in the preprocessor, which basically means if you have a macro and you concatenate in those macros to other macros, and the values of those 2 other macros are pound and define, and then you put another macro behind that, the MSVC preprocessor still evaluates that define, even though you concatenate it from other macros.
Right.
Which is technically not allowed in the preprocessors, but MSVC relies on it in some of the headers, or Windows relies on it on some of the headers, and both GCC and Clang actually implement that as well. But with a very big warning, you cannot turn off, please don't use this.
I like that, warnings that can't be disabled.
Yeah.
So you are also a bit of an evangelist for FASTBuild. For listeners who haven't heard of that, can you tell us a little bit about it?
Of course, yes. FASTBuild is a build system, like the name already says, and it has a focus on building your code very quickly, very fast. It has a few built-in helpers for that. For example, you can do Unity or so-called blob builds, where you have a bunch of object files, a bunch of C++ files, sorry, and then just concatenate them and compile them in one compile invocation. precompiled header support, so you can use precompiled headers on Windows, Linux, on all these supported compilers. And it has a very simple DSL, which is, I always say on purpose, not the Turing complete, although I don't know if it's actually not Turing complete. I have never tried to prove it, and I also don't know if it's on purpose, but I assume it is, because it's lacking a lot of features, which, as I talked to the author of FASTBuild, like there's no if construct. And he said, this is on purpose. Use something else. Like you can concatenate variable, or you can dynamically construct variable names. So you can still have an if, but you cannot miss out cases. For example, if you have flags underscore debug, flags underscore release, and then you want to get the flags values for your build type, you can say flags underscore and then build type, and then you get the value. And you would obviously get an error if your build type is not a variable, which allows to have a safe if. For example, in CMake, you could say, if this is debug, do that. On release, do nothing. So this could be an error, for example.
Well, let's talk a little bit more about what exactly you do with FASTBuild. Is this multiple platforms, or is it Windows only?
FASTBuild is available on any platform you would think it is available, or you want to use it. It's available on Linux, Mac, and Windows, and runs fine on all of them, although it is listed as an alpha build on both Linux and Mac on the website. I've been using it for like 2 years now, and I never had any problems, so don't take that as actual alpha quality. It works fine.
That's cool. Is it work with CMake at all? Because CMake's kind of our, de facto standard here for the C++ world.
Yes. No, it doesn't, unfortunately. FASTBuild is a lot different compared to CMake because it's not a meta build system. It does not generate any code or any project files for a different build system. There used to be a project trying to implement a CMake generator for FASTBuild, though. No, the other way around. Generating FASTBuild files from CMake.
Right.
But I think the last time I looked into that, it was like 2K commits behind master, and that's been 6 months ago. So I don't think that picked up again. It would be nice to have that though, because FASTBuild is actually pretty fast and has a caching mechanism, so you can, for example, stop using Ccache, and it has the distributed profile compiling, so you can have a build server somewhere in your attic, for example, with like 64 cores, and then just build over the network.
Yeah, that was the distributed compilation feature that made me think, if I could easily plug this in client projects that I'm already working on or something that are CMake, that would be really handy.
That would be really handy, yeah. I have to look into the CMake generator again. Maybe you can get that to work. That'd be pretty cool, actually.
That with the caching would be pretty awesome. So it says, though, that it does do Visual Studio and Xcode project generation.
Yes, it does do that. It doesn't do that on its own, though. That's the catch there.
Okay.
It basically has a generator has a function which generates a Visual Studio solution file or an Xcode project file, and you have variables which then gets filled in, which basically means you say, these are my source files, these are my include files, these are all my preprocessor defines, and here's the command you have to run when I press run or when I press debug, and then it runs that command. And usually you would just execute FASTBuild in the background. On my website there's a talk on FASTBuild, and it has a PDF with the slides. If you go to that and open that, you would see a screenshot of my Visual Studio, which has a bunch of targets, and I can compile with one click all targets, which includes Linux, Mac, and Windows in 2 flavors. One's MSVC and one's Clang.
Wow.
Which is a super, super powerful feature, because you just generate the solution file, and in the background you invoke the FASTBuild, but not actual Visual Studio.
And that automatically takes advantage of the distributed features to build on the appropriate platforms?
Yes.
Okay.
That's pretty darn neat.
It is pretty cool. And as far as I know, I think Ubisoft is using FASTBuild for their games. So it has some battle testing. And I've talked to one engineer at Riot Games who's saying he knows the engineer working on the FASTBuild, and they are using that internally as well. So it has some users in the game industry, and I'd love to have more users on FASTBuild, because it's pretty damn good build system, but it's kind of unknown. I've never heard about anything, and the user and the actual author is just silently working on it in the background and improving it. And he's actually really, really good. He responds really fast to all the issues you open, and he's been very nice and very, very good.
Are you contributing to the FASTBuild project yourself, or is it just this one author?
There are a bunch of people contributing to that. I haven't yet actually started contributing, but I'm in discussion, and I've opened a bunch of tickets on that, and they have made feature requests and everything. But there are a bunch of people working from AMD on that, for example, as well. Like there's this one girl one woman who has a bunch of comments on that, and a few other people. So there's some progress and some contribution from the open source community.
Do you know where it came from? Like what the author's original motivation was for this?
That's a good question.
Making a build system is a big project. I'm just...
It is a big project, especially a build system like that, because the usual build system you see is like, we take Python, we parse Python, we just write your source, your build files in Python or in Lua. He has written its own language. It has its own DSL, which is parsed. And FASTBuild as well is just a single executable. So if you need to install FASTBuild on your system, you just download that executable and put it in your path. Not like CMake, which is 300 megabytes or something big and requires an installer. You can just, in my case, for example, I even put FASTBuild into my repository, so I can just drop it in, and on the correct platform picks the correct FASTBuild binary and just compiles the project.
It looks like it's written in C++ also.
It is written in C++, yes.
That's it's cool. Interesting.
Yeah. Well, Arvid, what is your take on the future direction of C++? Are there any particular features you're hoping make it into C++ 20?
Maybe not 20, but I'm really sought after the meta classes. I have actually on my GitHub yet another shameless plug. I'm sorry. There's a GitHub project I've started. It's called Meta, and it is currently trying to implement context expression blocks in C++.
Oh.
Which is the project I teased in the beginning with. There would be a good Cling API would be very useful for that.
Okay. Because
right now I just parse the C++ source code using Clang, or libclang rather, and extract the context expression blocks, put them in a C++ source file, and pipe them to Clang, and then just get the output and invoke the actual compiler in a subprocess, which is kind of bad and kind of hacky, but works.
All right. I'm trying to visualize this. It's like you're doing like almost like in my mind, this is like a templated C++ file. You have like a chunk of code that you're saying, this part can be done at compile time. So you do that at compile time, then replace the code with the compiled version.
Exactly. Pretty much the current solution is I'm parsing the C++ code. I'm looking for the context for block. I extract the context for block, replace all the the dollar matter stuff, for example, which is not yet implemented, and replace all the dash greater sign blocks with printfs basically, and all the code. Put all the code in a main, execute that, and then put all the output into the C++ file. So it basically is a preprocessor to C++. So you can plug it into your build system, say this is the preprocessor now, please preprocess it, and then pass it to the compiler, which doesn't have to preprocess it anymore.
Wow. And it works?
It works for some very simple things, yes. I haven't yet had much the time I wanted to actually spend on it, but I really want to spend more time on it, and I hope on the holiday to spend some time on it.
How many of us take our vacation days to program on personal projects?
You got a lot of different products to choose from now, don't you?
Yes, and that's only scratching the surface.
Well, so we've been talking about all the projects, well, not all the projects, apparently, many of the projects you're working on, but we haven't actually asked you what you do at your work. You said you're the CTO of Appico. Do you want to tell us about that project, that product at all, that company?
Ironically, anything I do in my free time is kind of unrelated to what I actually do at my work.
Okay.
As the CTO, I'm just overseeing all the operations, all the engineering operations, and that usually requires me to jump into like any project we're currently working on, and if something goes wrong, I'm the guy who fixes that. So my time there basically is to pick up anything which is thrown at me. We've had a project where we implemented some backend for a postcard application in Node.js. Never written Node.js in my life before, and like, here's the backend. Please make this happen. Like, all right. We've got requests for writing custom Android distributions, for example. Like, hey, we want to make a tablet, and can you write us a custom Android for that? Like, sure. A lot of different stuff. Different companies, big companies, like we're working with Audi, we're working with Eventum, and we're focused a lot on the actual design. So I'm usually in the back, and if something goes wrong, it's my fault, but I'm usually just there to fix it.
Okay. Well, it's been great having you on the show today, Arvid. Where can people find you online?
They can find me on Twitter, twitter.com/Arvid Gerstmann, or if you are like probably anybody who doesn't know how to write their name, is arvid.io, arvid.io is my blog, and there you can find me. And on the CPP Lang Slack, I'm Arvid, so if you got any questions, please hit me up, and we'll always kind of try to respond in a timely manner.
And I believe the outfit that you've chosen to wear for our podcast, which has not going to be seen, I thought you were wearing your suit.
I'm not wearing my suit, but it is hanging right behind me.
Okay, I thought that was a silent shout out to your Slack friends there, because I could only see your shoulders. Those of you who are at Meeting C++ would know what we're referring to. If you weren't, then you should go to more conferences.
Absolutely, yes.
Okay, well, it's been great having you on the show today.
It's been fun.
Yeah, thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode is provided by podcastthemes.com. Website at cppcast.com. Theme music for this episode is provided by podcastthemes.com.